All right, guys, are there any questions on the homework? Any of the homework assignments? So what we're doing today and what we're looking at today is simplifying complex fractions. And really what we're talking about is having a fraction inside of a fraction. Now there's two ways we can go about doing it. One of them is going to be simplifying the numerator and denominator to one fraction and then dividing. And the other is using a least common denominator. So if we go on and look at this first one here, I'm going to show both methods. So I'm going to show the first method, well, first, and then the second method. And most likely, it's been about the same for most all the classes, y'all like the second method over the first. So I'm going to walk through the first method with y'all. You can watch this here. I wouldn't write it down if you don't want to, because you're going to probably prefer the second method first. Now, with the first method, what we need to do is get this denominator, which has two fractions, into one. And we need to do that by adding them together. Now, to be able to add these two together, we need the denominators to be the same. We need them both to be the same. So to do that, well, we're going to need to multiply both of these here so that we have the same denominator. Now the numerator, 5 over x plus 4, we don't need to do anything to because it's only one fraction. Now when we look at the 1 over x plus 4 and the x over, or 2 over x, well, the 1 over x plus 4, I need to multiply top and bottom by x over x, so that the denominator will have everything that the 2 over x has. And the 2 over x, I need to multiply it by x plus 4 over x plus 4. Because by doing this here, both denominators will have the exact same thing. Now when we do this multiplication, well, the numerator is going to stay 5 over x plus 4. Now the denominators, each one of these here, well, the first one we're going to have x times 1, which will give us x. And in the denominator, we're going to have x times x plus 4. The denominator for the other one is going to be x times x plus 4. Now in the numerator, we're going to multiply through by the 2. So 2 times x is 2x, and 2 times 4 is plus 8. Well, since we do have the denominators now finally the exact same, we can add the numerators. So on top we have x plus 2x, which is 3x. Because I have 2 and I add 1 more to it, we get a total of 3. Plus 8 over x plus 4. And this is what we wanted, because now that we've done the addition in the denominator, we have a single fraction on top and a single fraction on bottom. We have one fraction on top and bottom, and they're being divided. So really what we're looking at now is 5 over x plus 4 divided by 3x plus 8 divided by, well, it should be x times x plus 4. Yeah, I dropped that x for some reason. Shouldn't have. We get this here. Now, whenever we divide two fractions, well, we take it, change it from division to multiplication, and flip the second fraction. Well, if we're multiplying them together, they're going to all end up being on the same bar. So we'd really have 5 times x plus 4 over x plus 4 times 3x plus 8. But we do have something in common on top and bottom, the x plus 4 and x plus 4, which leaves us with 5x over 3x plus 8. Now at this point here, we would look at the numerator and denominator and see if we can factor or simplify in any way, shape, or form. Well, 3x and 8 don't have a greatest common factor. 5x is by itself, so that there is the final answer. So our final answer for this problem is 5x over 3x minus, or 3x plus 8. And that's our final answer. Any questions on this so far? No? Okay, well, I'm going to scroll back to the top and erase all this here. Now I want to look at this one again. What would happen if I multiply just the numerator by x plus 4? What would I get if I multiply 5 over x plus 4 by x plus 4? Well, this here would multiply by the numerator, so I would have 5 times x plus 4 over x plus 4, yes? What's going to happen to the x plus 4 over x plus 4? Cancel out, giving us just a 5, yes? If I did it to the 1 over x plus 4, we would get 1, because the x plus 4 over x plus 4 would cancel, yes? What would I need to do to the 2 over x? What would I need to multiply it by to get a similar result? X, because if we multiply it by x, we would have 2x over x, which simplifies to 2, yes? Well, doing something like that, well, if I multiply top and bottom by x plus 4, we know that it'll simplify the 5 over x plus 4, and that will also simplify the 1 over x plus 4. But the x plus 4 multiplication won't simplify the 2 over x, so we also need to multiply top and bottom by x. In doing this, we are going to simplify out all the fractions in the numerator and denominator. So I do this here on top, because each one of these, this whole thing is going to multiply by the numerators of the numerator and denominator of this complex fraction. So on top, we'll have 5 times x plus 4 over, bless you, x plus 4. In the bottom part, we're going to have x times x plus 4 times, well, 1, which is just going to be x times x plus 4 over x plus 4. Plus, well, here we're going to have 2 times x plus 4 all over x. Now let's see what simplifies. Well, on top we have the x plus 4 and x plus 4 is gone. And here we have the x plus 4 and x plus 4. And lastly, we have the x and, apparently I'm going to erase that, 2x. Those cancel out. Now looking at this here, what is left in the numerator? 5x. So the numerator is now just a whole number. We don't have any fractions left over. Let's look at the denominator. Well, for the first one, we just have x plus 2 times x plus 4. So that's kind of nice, isn't it? Because now in one step, we've taken it to having fractions in the numerator and denominator to just having one fraction. We've taken care of all the fractions in the top and bottom of this fraction in one step. The only thing that's left is to well simplify the denominator. So we can distribute that 2. We still have the 5x over x plus 2 times x is 2x, and 2 times 4 is plus 8. Well, x plus 2x is 3x, and we have our plus. Is that the exact same thing we got doing it by the first method? Which one do y'all like better, the first or second method? The second one? And that's all we have to do. Any questions on this here? Now, the first method does work, and there might be some cases where it is a little bit easier to do and solve it that way. But in others, it might be a little more difficult, especially if the numerator worked out to be 2 instead of 1, or if both the top and bottom end up being 3 instead of 1 or 2. But this here, I think, works a little bit better. So let's look at the next one. Now, the rest of these here today, we're going to do purely by the second method. I'm not going to do both. I only do the first and second method on the first so that y'all can see both, and then we kind of stick to the second method. So looking at this here, what do we need to multiply the top and bottom of this complex fraction by to get them all to simplify? Yes, we need an x minus 2 on top and bottom. And then an x. Because the x would take care of our 3 over x on bottom, and the x minus 2 would take care of the 6 over x minus 2, and the 1 over x minus 2. Now in this here, how many times does x minus 2 appear in our original equation? Twice. Why do I only need it once on top and bottom of what we're multiplying by? Well, in each fraction, how many times does x minus 2 actually appear? Once. It only appears once, but there's 2 places that it does occur, yes? The only reason I would need 2 x minus 2 is if one of these fractions had it twice. If it had it multiplied by itself twice, then we would need it twice. So we can go on and multiply these here. So the x times x minus 2 would multiply with the numerator of the numerator. So on top we would have 6 times x minus 2 over x minus 2. Then we would do the same thing with the denominator, multiply both of the numerators of the denominators with our x times x minus 2. Well, x times x minus 2 times 1 is, well, going to be x times x minus 2 over our x minus 2 plus. Then we'll do it with the 3, so we'd have 3 times x minus 2 over x. Any questions on this here before we start simplifying? So on top, well, the x minus 2 and x minus 2 would simplify out. On bottom, we would have the x minus 2 and x minus 2. And then we would have the x and x. which will actually leave us with 6x on top. And on bottom, we're going to have x plus 3 times x minus 2. Well, now all we need to do is simplify the numerator and denominator as far as possible, and we'll be done. Well, the numerator is just 6x. The denominator, we can distribute that 3. So 3 times x would be 3x. 3 times negative 2 would be negative 6. And well, x plus 3x is going to give us 4x minus 6. Well, 4x minus 6, we can factor out a 2. 4 and 6, do you have a common factor of 2? So if we factor the 2 out, I'm left with 2x minus 3. And if we simplify, because 6 over 2 would reduce to 3 over 1. So we'd end up with 3x over 2x minus 3. And that'd be it. Questions on this here? Now, in the grand scheme of things, it's not too bad from what we've been doing with addition and subtraction. Any other questions on this here? We ready for the next one? This one here is a little bit different because the denominators in the numerator and denominator don't have variables. Because we have 6, 3, 5, and 10. Now looking at all these here, we can still do the exact same thing. But this time, we need to find a number to multiply on top and bottom instead of one with a variable. So what is the smallest number that 3, 6, 5, and 10 will all go into? So we can do the factors of 3 out and see. So 3, 6, 9, 12, 15, 18, 21, 24, and we'll see if we need to go farther than that. Then 6, 12, 18, 24, 30, 36, 42. 5, 10, 15, 20, 25, 30, 35, yes. 10, 20, 30, 40. Well, 30 is the first number that has appeared, at least in those three, yes? And is 30 a factor of 3? Can I multiply 3 by something to get 30? 10. Because if we went out far enough, 30 would come up with 3 as well. So 30 is the first one that does appear. We could have also used 60, but it's not the smallest. If we use 60 at the very end, we would have had to factor out a greatest common factor of 2 extra than what we needed. So for doing this one here, we just need to multiply top and bottom by 30. Now if we do this here, again, we're going to multiply these by the numerators. Well, 30 times x is 30x over 6 minus 30x divided by 3. On bottom, we're going to have 30x divided by 5 minus, well, 30 times 7 is 210. Well, 7 times 3 is 21. So 7 times 30 should be 210. And we get this here. Well, now we just need to simplify each one of these fractions. Well, the first one that we have is 30x divided by 6. Well, 30 divided by 6 is 5, and we have x. 30x divided by 3 is going to be 10x. 30x divided by 5 is 6x minus 210 divided by 10 is 21. Now we can simplify the numerator because 5x minus 10x will subtract to give us negative 5x. Now the denominator, we can't simplify that in any way because we can't actually subtract those because they're not like terms, but they do have a greatest common factor of what? 3 that we can factor out. And if I factor the 3 out, 3 factored out of 6x is 2x minus 7. Will 5 and 3 simplify at all? No, there's not a greatest common factor between 5 and 3. Or really, to say 5 and 3 are not divisible. So that there is the final answer. How about 2? 2 more and we'll be done. All right. So we're going to do, here we go. I can go back. Okay. Did you finish writing it down? Okay. So we're going to do this one here and one more. Now, when we look at this one here, we do want to multiply the numerator and denominator by the same thing so that all the fractions in the numerator and denominator simplify out. So what would we need to multiply the numerator and denominator by for sure? Well, we need n x and n x, yes? Because the 2 over x and 2 over x. What else do we need? Because I'm thinking y'all are looking at the 3 and 4, yes? Do the 3 and the 4 have a denominator other than 1? No, so do I need to do anything to them? No, because the only ones we're needing to simplify are the 2 over x and the 2 over x. They're the only ones there's fractions inside of this fraction. So really, the only thing we need to multiply the numerator and denominator by for this one here is x over x. So if we do this multiplication with x over x, we actually get 2x over x minus 4x over 2x over x plus 3x. Well, here, the x over x will cancel, and the x over x will cancel, leaving us with, well, on top, I'm going to move the negative 4x up front, and that'd be plus 2. So I really just switched the negative 4x and 2 to get this here. On bottom, we can say 3x plus 2. Now there is a greatest common factor in the numerator that we can factor out. And we can factor out the 2. But I'd be inclined to factor out the negative 2. Because since the number in front of the variable on top is negative, I like it to be positive if I can. So I'll factor out a negative 2. which is really just going to change it from negative 4x to positive 2x. Well, it's going to change the sign in the middle from positive to negative, and we would have 1 over 3x plus 2. So we can have this here. Now we don't have to factor the negative out. We could have just factored the 2 out. And gotten this here. They both work. They're both the same answer. I would be more inclined to just factor the 2 out if, say, the denominator was negative 2x plus 1. Then they would both be the same, and we can just cancel them out. So either one of these work. Any questions on this here? Is there another one of these that y'all want to see done? So if you want to look through the rest of them, I'll let y'all pick the last one. Any of these, or the rest of these here that y'all want to look at? Huh? Want to look at that one? Let's look at this one here. So if we look at this one here, in the numerator we do have an x minus 4. But the x minus 4, neither one of these have a denominator attached to them in the numerator. The only one we have is 2x plus 3. So we'll need to multiply top and bottom by at least 2x plus 3. Is there anything else we need to multiply top and bottom by? No, because x minus 4 and x plus 3 don't have a denominator inside the numerator and denominator. They're already whole numbers. So the only one that we're needing to simplify anything is this one here or this one here. So 2x plus 3 over 2x plus 3 is all that we need. Now we will multiply each term in the numerator and denominator by 2x plus 3. So for the first, we'll have x times 2x plus 3 minus 4 times 2x plus 3 plus 9 times 2x plus 3 over 2x plus 3. In the denominator, we're going to do the same thing. So we'll have x times 2x plus 3 plus 3 times 2x plus 3 minus 5 times 2x plus 3 over 2x plus 3. Now looking at all these here, there is two things that will simplify. And that would be our 2x plus 3 over 2x plus 3 and 2x plus 3 over 2x plus 3. So in both of those spots, we will have it simplify a little bit. And in the rest of the spots, we can go on and multiply together because there's nothing that simplifies. So in the first one, our x times 2x plus 3, well, we can distribute the x. X times 2x is going to be 2x squared plus 3x. In the next one, we can distribute the negative 4, as long as I don't try to erase it. Negative 4 times 2x is going to be negative 8x. Negative 4 times 3 is going to be negative 12. And then we have plus 9. Because that last set of fractions on the top just simplified to a number. Over, well, exactly. So we'll distribute the x. which would give us 2x squared plus 3x. Now this time we're distributing a positive 3 plus 6x plus 9 minus 5. Well, at this point here, we can combine like terms. Which would give us 2x squared. 3x minus 8x would be minus 5x. And negative 12 plus 9 is negative 3. Now the denominator will still have 2x squared. 3x plus 6x is going to be plus 9x plus 4. So we get this here. Now most likely we'll need to factor the numerator and denominator before we finish this up. Is there one of these that y'all want to factor first? You want to factor the numerator or factor the denominator first? What do you say, Michelle? Denominator. So we have 2x squared plus 9x plus 4. Since the third term is positive, the signs are the same and they match the sign of the middle term, which is going to be positive and positive. Now the factors of 2x squared, well, we will have x and then 2 and 1. Because those are the only set of factors. They're both positive, so it really doesn't matter where we put them. We just need to put them in one spot. Now we need to look at the factors of 4. We have 1 and 4 or 2 and 2. Now did we have a greatest common factor before we started factoring this? Between 2, 9, and 4? Well, no, 2 won't go into 2, 9, and 4, all 3. So 2 and 2 is not going to work. So we need to do 1 and 4, and the 1 needs to be with the 2. So we don't have a greatest common factor in either one of the parentheses. And if we did check this, 2x times 4 is 8x. 1 times x is x, which gives us a positive 9x, which we wanted. So that one's factored. Now we need to factor the numerator. Now what we're hoping is that there is one of these sets of parentheses in numerator and denominator that are going to be the same. Now looking at this here, the 3 is negative, so our signs are opposite. We're going to have 1 positive and 1 negative. For 2x squared, the factors of x are x and x. And the factors of 2 are 2 and 1. Where do we want to put the 2? With the plus or with the minus? The plus. Because maybe those will match up. 1 and 3. And what do we hope the 1 is? Positive, and the 3 is negative. Now if we check this, 2x times negative 3 is negative 6x. 1 times x would give us plus x, which is negative 5x, what we wanted. So do we have something in common on top and bottom? And 2x plus 1, which actually leaves us with a x minus 3 over x plus 4. And that's as simplified as it gets. Any questions on this here? Well, with that there, we are done with this here. So the homework assignment for this here is on page 393, 39, 40, 42, and 44. So 4 problems. There are not multiple parts. So you actually just have 4 problems for homework tonight.